For this lecture, we will answer this problem. Hello? Okay. This is a Rankine cycle problem. 500 psi steam is superheated to 1000 degrees Fahrenheit before expanding to a 75% efficient turbine to 5 psi. No subcooling occurs and the pump work is negligible compared to the 200,000 kilowatts generated. What is the quantity of steam required and what is the heat ejected in the condenser? Okay, save ko lang to. Okay, first is we draw the TS diagram. So we always begin with the TS diagram when we're solving for Rankine cycle. Okay. Let's draw the TS diagram. TS. Okay. And then ang sabi sa problem ay .500 psi is superheated. Okay. Superheated to 1000 degrees Fahrenheit. So let's draw yung dapat a bit of slanting to the right. Slanting to the right kasi meron tayong straight line. Okay. And then, no subcooling. So, dito lang tayo mag-work along kasi walang subcooling daw. Okay. Let's label this as 0.1, 0.2, 0.3, and then 0.4. Okay. And then, given yung superheated steam mo ay 1,000, hindi, T2 pala. T2 is 1,000 degrees Fahrenheit. Okay? Pero, of course, ang pressure niya doon daw, 500 psi steam daw siya, is 500 psi A. Okay. And then, bit by bit, solve natin yung H and S sa kada point. Okay, so yun yung goal natin para malaman yung tinatanong na quantity ng steam at saka heat rejected in the condenser. Okay, kasi yung heat rejected in the condenser, we can solve that by getting H4 minus H3. So, yan yung QC. Ito yung QH. Then, dito may lalabas na work shaft. Diba? So, this is the turbine part. This is the boiler part, yung QH. Yung QC, yung condenser part. At the same time, kailangan i-multiply yan ng MFS. Para, hindi siya in terms of mass. In terms of time siya, rate siya. Ngayon, hindi natin alam yung H4 at H3. Kaya, bit by bit nga, kukuhain natin yung H kada point. Yung isa naman tinatanong, yung MFS, paano natin masosolve yan? So, yung MFS, dito yan manggagaling. Delta H ng isa turbine, kasi isa turbine times mass of flowing stream. So, further expanding that yan. kailangan natin yung H2 and H3. So, yung work shaft given na yan, yung sabi is 200,000 kilowatts. So, given yan. But we don't know yung H2 and H3. Doon tayo magsimula. Since superheated siya and sa 0.2, at 0.2, superheated siya. And may dalawa tayong parameters, yung T2 and P2, we can read from the steam table. From the steam table, yung H2, we can read that as 152, 0.3 BTU per pound mass. Okay? Paano naman yung 0.3? Ano na siya? Wet steam. Nasa loob siya ng saturated vapor region. Nandito siya, wet steam. Paano natin siya mababasa? Wala tayong any idea. So, ang pwede natin gawin, mag-assume tayo ng isentropic expansion. So, paano? Straight line lang siya. Oops, hindi yan straight line. Ito nga, oops. Ito siya yung dot. Straight line, yeah, that's the isentropic expansion. Let's label this as 3'. Okay, 3'. So, yung S2, basahin na rin natin yung sa 0.2 na S. Yan ay 1.7371 BTU per pound. So, if mag-a-assume tayo ng isentropic expansion, yung S3' natin equal lang sa S2. Mag-assume isentropic expansion equal sa 1.7371. Okay? So, ano ang natin? Kagagawaan sa natin magagamit yung S3'. We can guess, okay, an X'. Okay, yung quality niya, X3'. So, find X3'. As kung ano yung quality niya at this point to sa 3'. So, we have to know yung S3L at saka S3V. So, from the steam table, S3L is 0.23 BTU per pound Rankine. So, per pound Rankine yan. Hindi ko na nalagay yung unit, basta English unit yan lahat. Tapos, S3V from the steam table ay 1.8443. So, calculate natin yung S2', X3'. Paano? So, S3' is S3L times 1 minus X3', diba? Plus S3V times X3'. Substitute the values of S3', S3L, S3V, makukuha mo yung X3'. Hindi ko napapakita, substitute lang yan and use a solver. X3' is 0.9334. Okay. So, paano mo magagamit yan? Gamitin mo siya para ma-solve yung H3'. Okay? Use that. So, from the steam table, lagay natin dito yung H3L na 130. Okay? 130.2 at saka H3V na 1131.1. So, solve for H3'. Again, isentropic. Ito pa rin yung assuming isentropic. So, substituting all the values and x3 prime, makukuha mo yung h3 prime. Sige, sulat ko na rin. 3v times x3 prime. Ang makukuha mo dyan, pag sinubstitute mo ay 1064.44 BTU per pound mass. So, masasolve na ba natin yung mass of flowing stream na tinatanong? Malapit na kasi may efficiency na binigay. So, remember for turbine. So, for turbine, ang efficiency ay na binigay 0.75 sa problem. Ito siya, 0.75. Ano siya? Equal siya sa, ano yung nasa taas? Ano yung nasa taas? Pag efficiency ng turbine, yung mas maliit. So, mas maliit yung actual work. Okay? So, dito yung mas malaki yung isentropic enthalpy. Ang mas maliit yung Ang mas maliit yung isentropic change in enthalpy. Nasa baba yung turbine efficiency, ang mas maliit yung actual change in enthalpy. Mas malaki yung isentropic change in enthalpy. Okay, so sulat natin. Yung actual dito ay H3 minus H2. Diba? Tapos yung isentropic H3 prime minus H2. So, meron tayo nito, H2, meron tayo ng H3 prime, unknown, meron tayo nito, masasolve ba natin yung H3 prime, H3 actual pala? Yes. So, rearranging, tama, H3 prime minus, tama. So, substituting the values, H3 prime, so na yung H2, 1520. Times 0.75 na given. Solve natin. H3 actual ay 1178. .405. Now, masasolve na ba natin yung mass of flowing stream? Yes, masasolve na natin. Kasi, meron na tayong H3. Ito yung equation natin eh. Yan. So, mass of flowing stream kilojoules per second. So, given yan. Kilowatts is kilojoules per second. Tapos, minus, BTU per pound. 1520.3. kailangan natin mag-convert. We can convert, ano bang conversion factor? So, let's use the conversion factor na 0.9486 dito. Conversion factor. Okay, para ang lumabas pound per second. Sige. So, ang answer ay 554. Okay. By the way, magiging negative ang makuha nyo dyan kasi ang nilagay nyo ay work dapat is negative dahil this is work done by the system. Okay. Negative siya. So, work done by the system, negative. Para makuha nyo ay positive 554.53 pound mass per second. So, yan yung isa na tinatanong. So, yung next na tinatanong ay yung heat QC. Okay, QC. So, that's H4 minus H3. Meron na tayong H3. Wala tayong H4. Ano yung clues sa H4? 5 PSIA daw. 5 PSIA. So, yung P3 natin ay 5 PSIA. Kasi ang sabi, expanding to 5 PSIA. So, P3 is 5 PSIA. Since isobar yan, nasa loob tayo ng saturated curve. So, kung ano yung pressure dito, equal lang yan sa pressure doon. P4 is 5 PSIA din. Isobar yan. We can read. Tapos, alam natin na saturated liquid siya. Hindi daw lumabas ng subcooled region. So, alam natin na sa 0.4, ano siya? 0.4 saturated liquid. Saturated liquid at P4 equal to 5 PSIA. We read from the steam table. H4. Okay, isa lang parameter kailangan kasi saturated, ano siya, liquid. So, automatic mababasa na. BTU per pound. Okay. So, basically, we substitute that to our equation na H4 minus H3 times mass of flowing stream. So, 130.2 minus H3 na nasolve natin kanina. Saan ang H3? 1178.405. Times the mass, so this is BTU per pound, times yung mass of flowing stream na 554.53 pounds per second. So, BTU per second, kukonvert ba natin sa kilowatt? Pwede hindi naman sinabi. Pero, sige, BTU per second na lang. Ang masasolve mo dito ay negative dapat negative kasi heat is released. Yan. Okay? So, that's the answer. Double check, oh. Yes. Okay.